Welcome to The Explainer. Today, we're going to fundamentally shift how you think about music by uncovering its hidden mathematical fabric. Seriously, forget everything you know about melody just being pure emotion. We are going way back in time to decode the actual architecture of the cosmos.
Let's kick things off with a bit of a medieval paradox. How on earth could a university student master music without ever plucking a lute or singing a single note? It sounds completely impossible to our modern ears, right? But honestly, hundreds of years ago, this was exactly how music was studied.
Here's our roadmap to solve this mystery. We'll be hitting 1. The paradox, 2. The quadrivium, 3. The music of the spheres, 4. Divine ratios, 5. Mensural notation, and 6. The cosmic sync. We're going to connect medieval curriculums all the way to St. Augustine's philosophy on time, and finally to the complex rhythmic notations of 14th century monks. Let's dive in.
All right, Section 1. The paradox, and the instrumentless music major.
To really wrap our heads around this disconnect, we have to look at the medieval concept of scientia. As you can see, it meant knowledge of the relationships between humankind and creation. See, unlike today where we heavily separate hard science from art, scientia was all about understanding how humanity fits into the grand cosmic design. They weren't just trying to feel a fleeting emotion through art. No, they were actively trying to decode the universe.
Moving on to Section 2. Decoding the Quadrivium, the four liberal arts of quantity. So, to grasp this grand scientia, students had to master the Quadrivium. These were the four foundational mathematical arts. You've got arithmetic, which is discrete, pure numbers, geometry, continuous shapes, astronomy, continuous quantity in motion, and then music. Music was literally defined as discrete quantity, number, in motion through time. This brilliantly illustrates our paradox. To the medieval mind, music wasn't an emotional art form. It was literal math moving through time. You didn't need an instrument. You just needed a sharp mathematical mind to understand the proportions linking the lowest things to the highest.
Which brings us to Section 3, the music of the spheres, Boethius's 3 types of music.
To get why numbers mattered so incredibly much here, we have to look at the 6th century scholar Boethius. He categorized music into 3 distinct steps. First, you have musica mundana, the literal music of the universe, or the spheres. Second, musica humana, the music reverberating within the human body and spirit. And finally, musica instrumentalis, the music we actually sing or play. The crucial takeaway here is that played instruments were viewed merely as echoes of your own physical heartbeat, which in turn echoed the actual physical rotation of the planets. Through the lens of the Quadrivium, this was all just one giant interconnected mathematical harmony.
Let's look at Section 4. Augustine and Divine Ratios, the Theology of Time.
Now, what's really fascinating is how St. Augustine elevated these numerical ratios into something divine. He defined it clearly, musicae as science bene modulandi. Music is the science of measuring well. For Augustine, a piece of music was this highly rational enterprise. Ratios provided a literal bridge between our temporary physical world of sounds and the eternal realm of God.
Let's break down his logic for a second. He viewed God as the ultimate composer of the universe. Therefore, the ratios found in music directly mirror the ratios in creation. These numbers literally give our souls insight into the very nature of time. Think about it. The mathematical ratios in a melody, they don't change, even if the individual notes or instruments do. That relationship is eternal. He argued that the pure delight you feel when hearing a beautiful melody is actually your soul recognizing the unchangeable divine mathematics of the Creator. It's an intellectual and spiritual recognition, not just a toe-tapping reaction.
All right, Section 5, the math of mensural notation, putting the cosmos on paper. Here is where we see a massive shift in how all this theology translates into the practical writing of Western polyphonic music in the late 13th century. We move away from modal notation, which were those fixed, kind of rigid rhythmic patterns from Gregorian chant. Instead, we enter the era of mensural notation. Now, precise durations are based purely on numerical proportions. Every single note possesses an exact mathematical relationship to its neighbors.
To pull this off, composers started dividing time like it was a geometric shape. Tempus is the division of a larger note into smaller ones, and Prelatio divides those even further. They relied strictly on binary or ternary metric patterns. Essentially, they were building these hierarchical levels of meter that function a whole lot like our modern time signatures, literally mapping out the architecture of time itself.
And this brilliantly illustrates how the theology was baked right into the math.
Because of its connection to the Holy Trinity, a 3-beat subdivision was considered perfect, and they indicated that with a full circle on the sheet music. Meanwhile, a 2-beat division was deemed imperfect, marked by a semicircle. You can literally see the origin of our modern common time signature right there in that semicircle.
This number 3 absolutely dominated the rules of what theorists called imperfection and alteration. In practice, this meant a note could literally shrink or grow mathematically, losing a third of its value or doubling in length, based entirely on the notes surrounding it. The context dictated the math, constantly pushing the rhythm toward that perfect ternary division.
It gets even wilder with visual tricks like coloration. If you see notes marked in red ink or filled in solid black on a medieval manuscript, it meant they possessed exactly 2/3 of their normal duration. Composers like John Dunstable used these exact techniques to encode secret arithmological proportions directly into the sheet music. The manuscript itself became an esoteric map, literally a puzzle of divine ratios meant to be deciphered by the intellect of the singer.
And finally, Section 6, Listening to the Universe, the Final Cadence.
Even legendary astronomers like Nicholas Copernicus saw this deep connection to the Quadrivium. He wrote about being awakened to that which is best, and would not wonder at the artificer of all things, in whom is all happiness and every good. Copernicus viewed the mathematical perfection of the planetary spheres as a direct reflection of this divine artificer. The astronomer and the musician were looking at the exact same cosmic blueprint. They were just experiencing it through different senses.
So, what is the big takeaway from this explainer? Well, for centuries, music wasn't just entertainment. It was the study of proportion, bridging our physical senses and our higher intellect. The Quadrivium allowed humans to find this sameness of ratios across all of creation. Early polyphony, with its perfect and imperfect mensurations, was literally an esoteric map of the universe. Composers were essentially mathematicians reflecting cosmic harmony. They were building a mathematical ladder, allowing the human mind to climb from audible sound to the very mechanics of the cosmos.
Which brings us to our final thought. When you tap your foot to a beat, are you just enjoying a song, or are you physically syncing up with the mathematical ratios of the universe? Next time you hear a perfect harmony, I really want you to ask yourself, are you just enjoying a nice tune, or are you actively participating in the eternal music of the spheres? Thanks for joining me on this explainer, and keep listening closely.